Hi everyone, welcome to Go Classes. In this lecture, we will study addressing modes. Basically, in the previous lectures, we have already seen what is addressing mode. And now almost all the addressing modes we have already discussed. Now the remaining addressing modes we will see in this lecture. Okay, so let's start. So far, we have seen most of the addressing modes we have seen. We have seen your direct addressing mode, indirect addressing mode. We have also seen indexed addressing mode, PC relative addressing mode. So these topics we have already seen. Now in this lecture, we will study 3 more addressing modes. Okay, so let's start. So what are the topics we will discuss? You can see we will discuss this concept of relocatable code. We have already seen this concept in the previous lecture. What is relocatable code? That means position independent code. That means position independent code. Position independent code. Okay. So this concept actually we have already seen in the previous lecture. So we will just continue this concept. We will see how we can create relocatable code using base register. Okay, so there is a concept of base register. So we will see how we can create, how we can write relocatable code, how we can write position independent code with the help of base register. This base register concept we will study. Then we will see what is base register addressing mode. Okay, then two more addressing modes we will see. Those are auto increment, auto decrement addressing modes. Okay, so let's start the discussion now. In the previous lecture, we have already seen that relative addressing mode you can use to write relocatable code. Yes or no? Please tell me. So you can see in the previous lecture, this we have already seen that this relative addressing mode means PC relative addressing mode. You can use it to write, relocatable code. Okay. So this we have already seen. If you remember, for example, look at this program. Is this program relocatable? Tell me. Look at this code. Okay, this is your code. See, these are the memory addresses. These are the memory addresses, right? Okay, so I can say these are the physical addresses. Physical addresses means memory addresses. Okay, so these are your physical addresses. Remember, physical address means physical address. That means memory address. Okay, physical address that is same as memory address. Your memory that is also called physical memory. Okay, main memory that is also called physical memory. So that is a simple point. So physical address means memory address because your main memory that is also called physical memory. Okay, so you can see this is your code, right? I can say this is your code. This is the code. Now in this code, which addressing mode we are using? Please tell me. You can see in this code which addressing mode you are using. These are the memory addresses. You can see these are the memory addresses. So you can see we are putting the memory address in the instruction. We are putting the memory address in the instruction. Yes or no? What we are doing? Remember, we are putting the memory address in the instruction. We are putting the memory address in the instruction. We are putting the memory address in the instruction. So this is called direct addressing mode. Yes or no? So I can say this is your code with the direct addressing mode, with the direct addressing mode, or I can say absolute addressing mode. So I can say this is your code with absolute addressing mode. Now tell me, is this code relocatable? Is this code relocatable? So you can see this code, if you notice, this is a code with absolute addressing mode. This is not relocatable, right? Okay, this is a not relocatable. Means in the main memory, you cannot put it at some other place. Yes or no? Okay, your operating system, remember one thing, very simple thing, that your operating system, normally what happens, your operating system will run this process. Okay, and if some new process you want to run, then what the operating system will do? Operating system will suspend this. Okay, basically operating system will put this in the I can say backing store, and operating system will bring a new process in the main memory. Then when this new process execution is over, then what the operating system will do? Operating system will again bring this program in the main memory. But remember, when you again bring this program in the main memory, when the operating system will again bring this program in the main memory, then it is not necessary that you will bring it at the same address. Yes or no? Okay, when the operating system will bring this program again in the main memory, then it is not necessary that operating system will bring this program at these addresses. Okay, so that is called relocation. Basically, operating system can do the relocation of the program. This is your code. Operating system can do the relocation of this code. Means this code operating system can load at some other address. Okay, this program your operating system can load at some other address. But you can notice here one thing, that this code, if you look at this code which is using absolute addressing mode, you are using direct addressing mode. So this code, if you can notice, this is not relocatable. Okay, because what is the problem? If you relocate, then there will be problem. We have already seen in the previous lecture. You can watch the previous lecture. There I told you, like if you try to relocate, assume operating system has relocated. So this code, you can notice, this code you have loaded at this address 200. If operating system, assume operating system reloads this same code at address 400, then you can notice there will be problem. Yes or no? There will be problem, because what will happen, you can see this code, it should jump to address 411. If you look at this branch instruction, this branch instruction should jump here. Okay, means this branch instruction should jump to 411, but it will jump to 211. Okay, but this branch instruction will jump to 211. And remember, at the location 211, we don't know what is there. Okay, because your program, this is your program, and your program is loaded at this address. Okay, your program is loaded at this address. So we don't know at this address 211 what is there. We don't know. Okay, so there is a problem. So you can easily see that this code, look at this code, which is using the absolute addressing mode. This code is not relocatable. Okay, this code is non-relocatable. Is this clear? So very simple. This code is non-relocatable. Another name for this non-relocatable code, that is absolute code. This code is absolute code because it is using the absolute addresses. Yes or no? This is using the absolute addresses. So this is called absolute code. Remember, this non-relocatable code, this non-relocatable code, this is also called absolute code. What we call it? We call it absolute code, because here what we are doing, here in this relocatable code or absolute code, what we are doing, we use memory absolute addresses, or I can say memory addresses. Yes or no? We use absolute addresses, absolute memory addresses. Okay, so we use absolute memory addresses in the code. Okay, so that is the reason. Remember, this non-relocatable code, this is also called absolute code. Okay, so these codes, these absolute code or non-relocatable codes, these codes, they cannot be relocated. Yes or no? They cannot be relocated. You cannot relocate them. They cannot be relocated at some other memory address, at some other physical address, during runtime. Yes or no? Okay, once I can say they cannot be relocated at other physical address. Okay, at runtime. You cannot just keep relocating them. Okay, remember, very simple. So these non-relocatable code, these cannot be relocated at some other physical address. Okay, at runtime you cannot relocate them. Is this clear? Very simple point, right? Okay, now let's see, can we make it relocatable? Can you make this program relocatable? Your previous program, can you make it relocatable? Yes, we can make it relocatable with the relative addressing mode. Okay, if you use the PC relative addressing mode, then your program will become relocatable. Okay, you can see. So you can see now I am putting offset here. This is not the physical address, right? Yes or no? This is not physical address. This is not physical address, correct? Yes or no? This is not the physical address. This is just an offset. Okay, with respect to whom? This is just an offset with respect to whom? With respect to whom? Tell me, with respect to whom? Let me know. This is an offset with respect to program counter, right? Yes or no? So this is an offset with respect to, let me write here. This is an offset with respect to program counter. Okay, with respect to program counter. Yes or no? Very simple. So you can see this is an offset with respect to program counter. Similarly, this is also offset with respect to program counter. This is also offset with respect to program counter. Okay, so very simple. All these things you already know. Now tell me, is this program relocatable? Yes, this program is relocatable. Okay, you can relocate this program in the main memory at any address. Okay, you can relocate this program. Now you can relocate at any address, whatever address you want. For example, I can relocate this program in the main memory, in the physical memory at this address 400. Okay, you can easily see. Okay, because remember, I am not using the direct addresses. I am not using the absolute addresses. I am not using the physical addresses in my code. This is my code. In my code, I am not using the physical addresses. I am just simply using the offset. Okay. Now what will happen? You can easily see when you fetch this instruction, then program counter will have value 404. When I fetch this instruction, then the program counter will point to the next instruction. So the program counter has the value 404. Now what you will do? 404 plus 7. So you can see the branch target address, that will be 411. And yes, that is correct. 411, that is the correct branch. 411, that is the correct branch target address. Yes or no? So very simple. So you can see this instruction should jump to 411, and yes, it is jumping to 411. So there is no problem. There is no problem. So remember, very simple point, that relative addressing mode, this relative addressing mode you can use to write relocatable code. Okay. So now this is a relocatable code. You can relocate this code you can put in the main memory at any point of at any physical address. Your operating system at the runtime, your operating system can put this code in the physical memory, okay, at any address. So very simple. Okay, very simple. So this is relocatable. Tell me the answer for this question. Can direct addressing mode be used for writing relocatable codes? Let me know. Can direct addressing be used? Can I use direct addressing? Direct addressing means absolute addresses you are using. Absolute memory addresses. Memory addresses you are using. Okay, absolute memory addresses you are using. So can I use direct addressing mode to write relocatable code? And the answer is no. Okay, the answer is no. Is this clear? Very simple. So this is a simple point. This we have already seen. This point we have already seen. Whatever I told you, that is written here. Okay, you can read this after the class is over. You can read this from the annotated notes, or you can pause the video and you can read this. Okay, basically whatever I told you, that is already written here. You can easily see. In direct addressing mode, what happens? Read this. In direct addressing mode, operands are specified by providing the memory address, the physical memory address, directly in the instruction. The physical address, the actual memory address you are putting in the instruction. So this means that instruction will rely on fixed memory location. Yes or no? Instruction will rely on fixed memory location. Now it will making it difficult to move the code at a different location in the main memory. Yes or no? Is this clear? So very simple. You have, okay, if you want to relocate, then what you will have to do? Just tell me. If you want to relocate, let's assume you have a absolute code. Okay, then if you want to relocate, then what you will have to do? You will have to modify the instructions, right? Yes or no? You will have to modify the instructions. Okay, this is written here. So very simple point. So remember, very simple point. So for relocatable code, what is a relocatable code? Relocatable code means you can relocate this in the physical memory at any address. Okay, remember, relocatable code, that means that is position independent code. Okay, so that is independent of the memory addresses. So relocatable code, these are independent of the memory addresses, allowing it to be placed at different locations in the main memory without changing the code itself. Without changing the code, you can put it in the main memory at different locations. Okay, very simple. So for for if you want this facility, relocatable code, if you want, then you can use relative addressing mode, base register addressing mode. These addressing modes you can use if you want to achieve relocatability. Okay, is this clear? So very simple point. So direct addressing cannot give you relocatable code. If you want relocatable code, then these addressing modes you have to use. Okay, very simple. I hope you understood. Tell me the answer for this question. Can relative addressing mode be used to write relocatable code? This we have already seen. The answer is yes. Okay, the answer is yes. This is the answer. So you can use relative addressing mode to write relocatable code. Okay, and how you will do that, we have seen in the last class, if you remember. Okay, for example, if this code is given to you, how to make it relocatable? Very simple. Here, instead of this address, just put the offset. Yes or no? Yes or no? So basically, instead of this, just put offset. Okay, the offset you put, right? Is this clear? Instead of this, put offset. Instead of this, put offset. Okay, so basically, now this is your PC relative addressing. This is your PC relative addressing mode. Okay, now this is your PC relative addressing mode. So you can make it relocatable. Okay, so you can see basically just put the offset. This is the offset with respect to PC. This is a offset with respect to whom? With respect to program counter. Okay, so this is the idea. So just put the offset. Okay, we have seen how relative addressing mode can be used to write relocatable code. This point is clear to everyone. Please tell me. Please tell me how to use relative addressing mode. How to use relative addressing mode to write relocatable code that we have seen. Now let's see another way. Okay, now I will tell you another way, and this is better way. Actually, this is easier way. Better way and easier way. Let me tell you. Better and easier way to write relocatable code. Okay, now we will see another way to write relocatable code. If you want to write relocatable code, then there is a better way, there is an easier way, and that is using base register. That is using base register. Okay, don't worry, you will understand this. This is very simple. So using base register, you can write relocatable code very easily. Very easily. Okay, so let's see this. Our next concept, that is writing relocatable code using base register. I will write relocatable code. I will write in front of you. I will write, okay, using base register. Now, let me tell you what is the concept. See, the concept is like this. Now, remember, our topic is what? Our topic is we want to write relocatable code with the help of base register. Okay, so there is a base register in the CPU. In the CPU, there is a you know your CPU. In the CPU, there is a base register. Okay, you have a base register. This is your base register BR. Let me call it BR. Okay, what is BR? Please tell me what is BR. That is your base register. Okay, that is your base register. So in the CPU, there is a base register. Okay, now what will happen? See, you will write your code in the high level language, right? Okay, you will write your code in the high level language. You tell me one thing, when you are writing your code in the C language, for example, it's C language, do you give the line number in your code? Do you give the line number? Like, do you write the line number? Do you give the addresses when you write a high level language code? In your C language, if you write a code, do you write the line number? Will you write the line number? Do you write the addresses? No. Okay, you have a very simple sample code. Okay, man, something, 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 something. So this is your code. Now what, who will convert this? Who will convert this? You can see, you will compile it. So what the compiler will do? Now this is interesting. What the compiler will do? Now remember, our target is to write relocatable code, okay, with the help of base register. Now what the compiler will do? Okay, notice what the compiler will do. Compiler will do something like this. Actually, compiler will, you can see, you will have instructions. Okay, compiler will convert your code into assembly language. Agree with me? Compiler will convert your code into assembly language. So compiler converts into assembly language. Okay, into assembly language. So you can see what will happen. This compiler will convert your code into assembly language. And what this compiler will do, remember, what this compiler will do, when this is converting to assembly language, this will give only labels. Like, this is the line number 0, this is the line number 1, this is the line number 2, line number 3, line number 4, line number 5, and so on. Are you getting my point? Please tell me. I2, I3, I4, I5, and so on. Okay, is this clear? So what your compiler will do, this is what your compiler will do. Is this clear? Remember, you have a high level language code, whatever code you have, your compiler, what it will do, it will convert your code into assembly language code. What it will do, it will give line numbers. See, these are simple line numbers. Are these physical addresses? Tell me, are these main memory addresses? These 0, 1, 2, 3, 4, 5, are these main memory addresses? These are not physical addresses, right? These are not physical addresses. These are not physical memory addresses. Yes or no? These are not addresses. These are not addresses. What are these things? What are these things? These are simple labels. Can I call them labels? These things, what I will call them? These things. simply I can call them labels. Okay, you can call them labels, you can call them labels, or you can call them offset, no problem. Okay, so remember, these are just labels, offset, line number, whatever you want to you can call. So this is what the compiler will do. Is this understood so far? Okay, so far is this understood? So basically your compiler is going to do this. So remember, your code, your high level language code, okay, your C language code, that will be converted by whom? By compiler. The compiler will convert it into the assembly language code, and this compiler is going to do this, that it will write like this, that okay, it will write like this, starting from 0, line number 0. At line number 0, let's assume some instruction I1 is there. At line number 1, let's assume some branch instruction is there. Okay, let me put some jump instruction there. Let's assume you want to jump to locus in line number 5. Tell me where you want to jump. Where you want to jump? At the physical address or at the line number 5? At the physical address or at the line number 5? This is line number 5. Okay, means at this line number 5 you want to jump. Okay, you want to jump to line number 5. Okay, because everything compiler is doing. This program, we are so far we did not load in the main memory. Yes or no? Array, this program so far, this is not even in the main memory. If this is not in the main memory, how can you have these physical addresses here? So these are not physical addresses, because you are just doing the compilation. Your code, your compiler is doing the compilation. So these line numbers will be given. Okay, remember, there is no right now there is no physical address. Okay, so you will jump to 5. Let's assume at this, let's assume you have I3. Okay, at this, let's assume you have another jump instruction. Okay, another branch instruction. Let's assume there is some branch instruction, means okay, branch if 0. Okay, branch if 0 to location 0. Okay, to location 0. Is this clear? Now you can see, after that, let's assume line number 4 is some other instruction, maybe I5. So let me start with I0. Okay, just for simplicity, let me start with I0. That this is your instruction I0, this is your instruction I2, this is your instruction I4. Okay, at 5 there is another some instruction I5, there is some instruction I5. Is this clear? And so on and so on. Okay, so at this step, let's assume there is some data also. Okay, let me put some data also. Interesting. Let's make it interesting. That add. Okay, add at location 6. Okay, at location 4 5 6. Okay, let me do like this. What it means? Tell me what it means. Let me know what this instruction means. What this instruction means. Here, let's assume you have data. Here you have operand. Okay, operand. Here you have operand 1, operand 2, operand 3. Okay, now this is correct. Is this clear? Please tell me. Okay, so far understood? Tell me. So your compiler will basically give this. This is what your compiler will generate. So these are just labels. These are not physical addresses. You know, these are just labels, or you can call them offsets. You can simply call them line numbers, whatever. Okay, line numbers. So this is what compiler will generate. And what is this one? What is this 5? Again, this is a line number. Yes or no? Again, this is a label. This is not a physical address. This is just a label. Okay, this is just a label, not physical address. This is not your memory address. This is not your memory address. This is just a label. Okay, or I can say line number. This is just your line number. This is just your line number. Now, what this instruction means, let me just tell you. You might be thinking, sir, what this instruction means? This instruction means what? Okay, this instruction means operand 1, let's call it X, operand 2, let's call it Y, operand 3, let's call it Z. So this instruction simply means that in X, you have to put Y plus Z. Okay, this is what you have to do. Is this clear? Please tell me. Okay, so this instruction simply means that at address, what you have at address 5, 6, what you have at line 5, 6, add these two and put in the line number 4. Okay, so this is what you have to do. Is this clear? Means this instruction simply means what you have at line number 5 plus what you have at line number 6, put that in the line number 5. Okay, so this means content at line 5. Okay, so this is what you do. Is this understood? Please tell me. Let me know. Is this understood? Now let me just write these branches. The see, this is going where? This should go to where? So let me instead of this 5, let me write it is jumping to, let's assume, somewhere else. Okay, so for simplicity, jump it to let me jump it to, so at 7. Okay, take 7 also. So anyway, so where should I make it jump? See, I should make it jump to some instruction, right? Okay, I should make it jump to some instruction. I should make it jump. So let's assume I'm making it jump to 3. Okay, no problem. Okay, just forget about it. Just jump it to 3. Is this clear? Randomly, I'm writing. See, okay, just to explain the concept, I'm writing this. Okay, so you tell me now, just to explain the concept, because remember, you have to jump to some instruction, right? Yes or no? The jump instruction, it will jump to some instruction. Okay, it will jump to some location where you have instruction. Okay, right? Add instruction, it will jump to some location where you have operand. See, this instruction will jump, basically this instruction will take operands, but this will jump to some location where you have instruction. Okay, now let me just give you this, that this will point to, basically, remember, this should jump to, or I can say this should jump to this location. Okay, remember, this 3 should jump to where? This should jump to where? This should jump to the here. Okay, clear? And where this add instruction will go? Where this add instruction will basically fetch? This add instruction will fetch from here. Okay, add instruction will point to these. Okay, is this clear? Please tell me. Now, okay, now let me tell you why. Now I am telling you that this is your relocatable code. Okay, now this is your relocatable code. This is your relocatable code. Why this is relocatable code? I will tell you why this is a relocatable code. Okay, first of all, you tell me, just tell me one thing. This is much easier than the PC relative addressing mode. Do you agree with me that this is much easier than PC relative addressing mode? In the PC relative addressing mode, you have to make the calculation. Okay, what will be the PC value? Then offset, you will have to calculate the offset, right? This is very simple. Just put 0, 1, 2, 3, 4, 5, 6. Yes or no? Just put the line number. Yes or no? Please tell me, did you understand? Let me know, do you agree with me that this is much easier than PC relative addressing mode? See, in the PC relative addressing mode, you have to calculate what is the offset with respect to PC. Means if you are calculating the offset for this instruction, then you will have to calculate with respect to this instruction, right? Because program counter will have value 2. When you fetch this instruction, program counter will point to this instruction. So you will have to calculate displacement from this instruction. You will have to calculate displacement or offset from this instruction. Okay, so this is what I'm telling you, that in the PC relative addressing mode, you have to do a lot of calculation, all those things you have to do, but this is very simple. I'm saying that this is relocatable code. Okay, and I will prove it to you that this is relocatable code. Just one thing I need. See, now let's assume operating system has loaded this program at some address. Now what operating system will do? Now this is your compiled code. Okay, now this is your compiled code. Okay, yes or no? Now this is your compiled code with labeled addresses. Yes or no? You have just labeled addresses. You don't have physical addresses. You just have labeled addresses. Yes or no? So this compiled code, now let's assume you are loading this. Okay, you are loading this in the main memory. Finally, you are loading this in the main memory. Okay, so in the main memory, now you are loading this. Okay, so the operating system can load this at any address, at any physical address. Okay, yes or no? Operating system will load this at any physical address, some physical address. Let's assume, let's start with 200. Okay, at physical address, you will load this program, right? Okay, now let me put this at the 200. Now you tell me, if you put it at the 200, now what will happen? These will become physical addresses. Yes or no? These things will become physical addresses or not? Please tell me. These things will become physical addresses or not? Let me know. Because now you are loading in the main memory. Now your program is in the main memory, remember. Now where is your program? Now your program in main memory. Now program is in main memory. Is this clear? Now program is in the main memory. So if this program is in the main memory, then all the instructions, they will be at the physical addresses. Okay, yes or no? Is this clear? See, now your program is in the main memory. So all these instructions plus data, these are instructions plus data. So these will be in the main memory. This will be at some memory location. This will be at some memory location. This will be at some memory location. So basically now you will have physical addresses here. Okay, now what you will have? You will have physical addresses here. Like if you are loading at 200, let's assume I am loading at 200. Okay, now this is a physical address: 201, 202, 203, 204, 205, 206. Okay, now these things, are they line number or physical addresses? These things, are they line number or they are physical addresses? These things are actual physical addresses, actual physical memory addresses. Okay, these are not line numbers. These are actual physical memory addresses. Means in the main memory at this location I0 is there. Okay, in the main memory at this location I0 is there. In the main memory at this location jump instruction is there. So these are actual physical addresses. Okay, now you tell me, so just what should I do right now? Something is like something is not making sense. Yes or no? Do you agree with me? Something is not making sense. You have to jump, like this instruction should jump to this instruction, right? Yes or no? Notice this instruction should jump to this instruction. So what should we do? Anyone has any idea? See, remember this instruction. You can see this arrow. Look at this arrow. This instruction should actually jump to this instruction, right? So, but this 3 is there. So what is the idea? What is the idea? If I actually put 203, will it make sense? If I actually put 203, now will it be correct? If I actually put 203, will it be correct? But if I actually put 203, then will it be relocatable? Please tell me. If I put the physical address here, will it be relocatable? Our target is to make relocatable or not? Please tell me. If I put 203 here, if I put 203 here, then this is not relocatable. Now this is not relocatable. So I cannot put 203. Okay, yes or no? I cannot put 203 because this is not relocatable. Also, can you put 203 once you are in the main memory? Once your program is in the main memory, can you change your instruction? Please tell me, once your program is in the main memory, can you change your instruction? You cannot change it. When can you change your instruction? Who can change your instruction? Who has the power to change the instruction? Who has the power to change your code? Either you or the compiler. Yes or no? Because the compiler will generate these labels. These labels, all these things are generated by the compiler. Okay, so remember, you or the compiler has the power. So you can't even change it. So don't think about changing the code. Do not think about changing the code. Remember, you cannot change the code. No, you cannot change the code. So how to make everything right? Because this will jump to 3. Yes or no? Because this will actually jump to 3, but it should jump to 203. So how to make it right? Any suggestion, anyone? You understood my concern, right? Yes or no? You understood my question? You understood my doubt? Okay, because remember, when you load this program, this was your nice program. After the compilation, this is a nice program. These are the line numbers. This is a nice program. But once you load it in the main memory, your code, once you load in the main memory, then everything will be at a physical address. Everything will be at a physical address. Everything will be at a physical address. Yes or no? Okay, everything will be at a physical address. So these things, this instruction will be at address 200. This instruction will be at address 201. Now what to do? Yes, very good. Just small thing you do. What you do, where you are loading your program, just put this in the base register. That's it. Okay, just put this in the base register. Okay, where you are loading your program, just put this in the base register. Only this small thing you do, that's it. Only this small thing you do, that's it. Okay, now what will happen? In the base register, you put the code, you put the address, you put the physical address. This is actual physical address. This is the physical address where program is stored. This is the physical address. Remember, this is the actual physical address. This is the actual physical address where program is loaded. Where program is loaded. Where program is loaded. Is this clear? This is the actual physical address where program is loaded. Very simple. So just put this in the 200. Now what CPU will do? Now what CPU will do? Now what the CPU will do? Now CPU does this. Now CPU does this. Okay, CPU, what the CPU will do? CPU will do this for every address. For every address generated by the instruction. Okay, given by the instruction. For every address of in the instruction, inside instruction. Okay, for every address inside instruction. In the instruction, there is an address. Okay, so remember, for every address inside instruction. Okay, let's assume this is your address. Actually, that address, that is offset. Okay, address inside the instruction, that is actually offset. Yes or no? That is actually offset. Let's call it A. Let's call it A. But that is actually offset. So you can see for every address A inside the instruction, what your CPU will do? CPU will do this base register value, the base register content plus A. This will be effective address. This is going to be effective address. That's it. Very simple. Means what you do, means what it means. It simply means that now this is going to happen. C. Now what the CPU will do? Now let me remove this. Now very simple. Now what this 3 will mean? What this 3 will actually mean? What this 3 will actually mean? This 3 will actually mean 200 plus 3. That is correct, right? Now it is correct or not? That is correct or not? This 3 will actually mean 203. Okay. What this 6 will actually mean? What this 6 will actually mean? Please tell me. What this 6 will actually mean? This 6 will actually mean 200 plus 6. Okay. What this 0 actually mean? What this will actually mean? This will actually mean 200. Everything is perfect or not? Just tell me, everything is perfect or not? Let me know. Everything is perfect or not? Please tell me. Yes, that's it. Your program has become relocatable. Now you can relocate at any address. See. Okay, I'm relocating. Tell me at which address I should relocate. Okay, I'm relocating. You can relocate at any address. Let me relocate at 400. Let me relocate at 400. No problem. No problem. Let me relocate. I'm relocating at 400. Okay, relocation. Now we have done the relocate program at 400 at memory address 400. Which changes you have to make? Just tell me all the changes that you have to make. No changes. Operating system is relocating. Who is relocating? Tell me, who is relocating? Operating system is relocating. Yes or no? So this change who will make? This change who will make? Operating system will make. So this 400 you will put here. Operating system will make this change. Okay, because operating system is doing the relocation, so the operating system will put 400 in the base register. Now everything is very simple. Put basically every address will be calculated like this. Every address will be calculated like this. 400 plus 3, that is 403. Yes or no? Every address will be calculated like this. 400 plus this, 400 plus this. So everything is perfect. So this has become relocatable code or not? Just tell me. Just tell me, this has become relocatable code or not? So that's it. This is the idea. I hope you understood. Okay, so this is the final conclusion I'm giving you. Basically, how to make. We are writing relocatable code using base register. Writing relocatable code. This concept, did you understand? We are writing relocatable code using base register. The name itself is telling you or not? Base register. The name itself is telling you base register. It will contain the base address where program is relocated. Okay, this will contain what it will contain? This will contain base address. This will contain base address of program. Okay, where OS has relocated the program, where a OS has loaded or relocated the program. Yes or no? Okay, very simple. So the base address will, this base register will contain the base address. Now everything is very simple. Remember, you have a base register. This is your base register. Here you will have the base address. For example, let's assume 200. Now you have your code. Your code is something like this. At 200, you have instruction 1. At 201, you have instruction 2. At 200, okay, you have instruction 3, and so on. Okay, these are actual physical addresses. These are actual memory addresses. Memory addresses. Okay, and remember, if you have some kind of thing, for example, if you have here, let's assume you have jump instruction 9. Now what you will do here, then what it will mean, what is the target address? Tell me, for this, what is the target address? What will be the branch target? What will be the branch target? The branch target will be 200 plus 9. That's it. That will be 202. Sorry, you can see. Yeah. Okay, with respect to everything will be with respect to this branch register. Remember, everything will be with respect to this. Okay, every address of the code will be with respect to this. Is this clear? So that will be 200 plus 9. Okay, is this clear? Please tell me. Let me know. Because actually what this means, okay, if you did not understand, because actually what this means, actually this means like this, that you have your code is something like this, 0 1 and so 9. You are jumping to 9. Okay, and at line 2, what you have at line 2, you have jump 9. This was your code, yes or no? This was your code at compile time. Okay, this was your code after compilation. This was our code after compilation. After compilation. Okay, this is our code after compilation. Is this clear? So you can easily see that you will jump to 2209. Very simple. So this is the idea. Understood? So the branch target address also we have calculated. So very simple. Everything will be with respect to branch register. So this is very easy. Yes or no? Is this clear? Did you understand? Did you understand this? So making relocatable code is very easy now. Agree? If you want to create relocatable code, if you want to write relocatable code, that is very easy now. That is very easy. Okay. Is this clear? So remember, very simple. You can see here, when the operating system will load the program, read this. When the operating system will load the program, what it will do? What operating system will do? When operating system will load the program, what it will do? Will load the program. It will set the base register to the physical address where the program should start, and the CPU will add. And what the CPU will do? The CPU will add this value to every address that the process will use. Okay, is this clear? So very simple. Remember, in this base register code, okay, I can say in this base register addressing mode. In this base register addressing mode, actually what happens, let me tell you. In this addressing mode, remember one thing, what will happen? Your instruction, let's assume you have instruction. I am telling you what is base register addressing mode. Let's assume this is your instruction, and in this instruction, this value you have. This value you have. Tell me, what is this value? Anyone want to tell me what is this value? This value, what is this value? This is simply offset. Okay, this is simply offset with respect to whom? With respect to whom? With respect to base register. With respect to base address. Okay, with respect to base address in base register. In base register. Okay, so you can see this is offset with respect to base address in base register. So this is the idea. Understood or not? So remember, what will be the effective address? The effective address will be content of base register plus this value A. Okay, plus this value A. So there is a base register. There is a base register. Okay, and it has the what is the content of base register? That is the base address of program. That is the base address of program. Okay, here you have the actual physical address. Yes or no? Here you have the actual physical address. Here you have the actual physical address. Okay, and that is the base address of the program in main memory. In a main memory. So is this clear? What is base register addressing mode? Will you forget it in your lifetime? Will you forget it in your lifetime? What is base register addressing mode? So very simple, right? Yes or no? Base register. That's very simple. Base register. Base register addressing mode. Okay. Base register will contain what? Just tell me one thing. This base register, what it will contain? This base register will actually contain the physical actual address, right? This is the actual physical memory address. Physical memory means main memory. This is the actual main memory address. Okay. Where program has been loaded. Where program is loaded. In memory. Where program is loaded in memory. Okay. So that's it. Now, very simple. I hope you understood. So this is the concept. And did you understand the application of base register addressing mode? Very simple. Using the base register, you can create relocatable code. We can create relocatable code. Okay. So this is the simple idea. One question I want to ask, one difference you tell me in the PC relative addressing mode, in the PC relative addressing mode and in the base register addressing mode, you tell me the difference of offset. You tell me the difference of offset. In the PC relative addressing mode and in this addressing mode, you tell me the difference of offset. Means here tell me the offset was unsigned or signed. What was this? And here this offset should be signed or unsigned. In the PC relative addressing mode, remember this is PC relative addressing mode. Okay, or I can say relative addressing mode. In this addressing mode, if you want to jump at some location, let's assume you want to jump at this location. Let's assume you want to jump at this location. Okay, from here, basically you want to jump at this location. Okay, you want to jump at this location. Now you tell me what your offset value will be. What your offset value will be. This offset value. This offset value, what that will be? You can see that will be 201 minus 190. 201 minus 190, that is 11 minus 11. Yes or no? That will be minus 11. Yes or no? Is this clear? That will be minus 11. So this offset should be signed. This should be signed number in 2's complement. Okay, because signed numbers mostly we represent in 2's complement. Remember, signed numbers we mostly represent in 2's complement. By default, we represent in 2's complement. What do you think? In base register, will you ever need negative offset? Just think about it and tell me. Will you ever need negative offset? Will you ever need negative offset? No, no, no. Because your first instruction is here. Just think about it. Your first instruction is here. Okay, your first instruction itself is here. So you can see your first instruction itself is here, and so on, and so on. And your base address, base register contains this address 200. Okay, this address is in the base register. So you can see, and the effective address will be what? The effective address will be this 200 plus this value A, whatever value A you have. Okay, whatever value A you have. For example, if I write here jump A, so the whatever value A you have, effective address will be 200 plus A. This is fixed. So offset will be usually unsigned. Okay. So if nothing is given, this is very simple. This is unsigned. Understood? So all these simple concepts you are understanding, right? You don't have to by heart. See, every simple thing, every small thing I'm telling you that you can easily understand. You don't have to by heart that in the PC relative addressing mode, offset will be signed number. In the base register addressing mode, offset will be unsigned number. These things, do you have to by heart or can you understand? Now you can understand, right? Also, this thing, can you understand that we can use this to write relocatable code? We can also use this addressing mode to write relocatable code. We have also seen how to write relocatable code using this mode and how to write relocatable code using this mode. So both we have seen. Which is more easier to write relocatable code? Of course, both are fine, but which is more better? Which is more better approach? This is a better approach. Yes or no? Is this clear? So remember, to write relocatable code, to write relocatable code, if you want to write relocatable code, to write relocatable code, to write relocatable code, remember this, you can use relative addressing mode also. You can use relative addressing mode also. We have already seen how to write relocatable code using relative addressing mode. We have already seen. You can also use base register addressing mode. That also we have seen how to write relocatable code with help of base register addressing mode. Which is more relevant? Which is more relevant? This is better. Yes or no? I can say this is more better approach, better or more relevant. Okay, this is more relevant, or I can say better, but yeah, this is also fine. So you can use this also, you can use this also to write relocatable code. But remember, this base register addressing mode, this is much easier approach. This is much easier approach. So I can say this is mostly used. Okay, this is mostly used. And for branch instructions, we mostly use relative addressing mode. Okay, for branch instructions, remember, for branch instructions, we mostly use relative addressing mode. So remember, which is more popular? If someone asks you, for branch instruction, who is more popular? For branch instructions, who is more popular? For branch instructions, if you have jump instructions, then for these instructions, I can say relative addressing mode more popular, more popular, more popular. Okay, so you can see relative addressing mode, that is more popular than base addressing mode. Then that is base register addressing mode. And if you want to write relocatable code, then if you want to write relocatable code, then if you want to write relocatable code, of course, both you can use. Remember, I am just saying which is more popular. I am just saying which is more popular. Of course, you can use both of them. Of course, you can use both of them. Okay, so for relocatable code, I can say this base register addressing mode is more popular. Okay, addressing mode more popular. This is more popular. Okay, so I hope you understood. Of course, you can use both of them. Of course, you can use both of them, that we have already seen. Okay, so everything you understood. You don't have to by heart anything. Okay, this code with the help of base now you convert this. This is my question. This is my question. You just take this question, convert, make it relocatable with help of base, make it relocatable, make it relocatable using base register addressing mode. How you will do? Using base register addressing mode. How you will do? In this code, just focus on the branch instructions. Okay, in this code, just focus on the branch instructions. So when I say make it relocatable, then I am talking about these branch instructions. Okay, I am talking about these branch instructions. These branch instructions I am talking about. Is this clear? So make it relocatable. Let's make it relocatable using base register addressing mode. How you will make it? Please tell me. How are you going to make it? Using base register addressing mode. So in the base register, what you will put? Just tell me that point. In the base register, what you will put? In the base register, you will put 200. Very simple, very simple. Okay. Now, what you will do? Instead of this 211, what you will put? Instead of this 211, you will just put 11. That's it. Yes or no? Isn't it very simple? Okay. Instead of this 202, you will just put 2. You will just put 2. Okay. And you can see instead of this 235, you will just put 35. Can you feel that this is much easier? Can you feel this is much easier? Yes or no? So you tell me, what is this? This is offset with respect to whom? This is offset with respect to 200, with respect to base register content. Base register content. Is this clear? This is with respect to base register content. Okay, simple, right? So very easily you can do this. This is what I'm telling you. So this is offset. with respect to base register content. So quite easy. And this 200 you will put here. This actual physical address, this you will put in the base register. Okay. Now this is much easier. And the same code using PC relative, in the last lecture we have done it. Using PC relative, you have to use your brain, right? Yes or no? Using PC relative, you have to use your brain. In the last class, we have done this. If you remember, in the last class, we have done this. So here you will have value 7. In the last class, we have already done this. Here you will have value 7, here -9, and here 9. Okay, this we have done in the last class. This we have done in the last class. So using PC relative, this is what you will get. And using base register addressing mode, this is what you will get. Now you have become expert. Okay, now you have become expert. Is this clear? Very simple. You have already become expert. Okay, so I hope you understood. So this is the point. When the operating system will load the program, it will set the base register to the physical address, where the program should start. Okay, so remember where the program should start, and CPU will add this value to every address that the process will use while execution. Okay, very simple. So this is the base address. It will contain the physical address. So we have seen this. Now let's move on. So this is your base register. What is base register? The base register will hold the physical address. It will hold the physical address of the location where the program is located in the physical memory, and thus it will allow for relocation of the program in the physical memory. This is the definition of base register. If someone asks you what is base register, you can say this, that the base register will hold the physical address where the program is located in the main memory, and it will allow for relocation of the program in the physical memory. So this base register addressing mode, we have already seen. In this, what your instruction will be? This is your base register addressing mode. Your instruction will be what? Your instruction will have some value A. Yes or no? Your instruction will have some value A. Okay. Your instruction will have value A. In this situation, what I am assuming, if you have only value A, then in this situation, it means your base address is explicit, special purpose or general purpose. When base register is implicit, yes or no? When base register is implicit, or I can say special purpose. Okay, so when the base register is implicit, or I can say special purpose register, then you don't have to mention it. So you can see, when the base register is implicit, in this situation, you don't have to mention it. In this situation, you can just say what the effective address. Tell me the effective address will be this value plus the content of base register. And this will be your offset. This will be your offset with respect to content, base register content. So quite easily you can do. Okay, and the same thing, if that is explicit, when that is a general purpose register. Okay, when that is a general purpose register, in this situation, you have to mention it. In this situation, you have to mention this register. Okay, this register R you have to mention. Okay, so this R is your base register now. In this situation, very simple, just do this. Okay, so this is the idea. I hope you understood. So this is your concept. You can see base register addressing mode. In this addressing mode, what we will do? Base register addressing mode, the interpretation. What is the interpretation? That is basically the content of address plus the displacement. Okay, just add both of them. So you can see, you can read this. We have already seen this, and you can use this for what purpose? The base register addressing mode is used for what purpose? Okay, to facilitate relocation of program in main memory. Is this clear? So you can see, very simple. So this we have already seen. You can read this. We have already seen this. Everything we have seen, and with very clarity. See, everything that I've taught you, Remember, whether I taught you PC relative addressing mode, indexed addressing mode, and base register addressing mode, I want to tell you one thing. These three things, many students, they know these things, no, but they don't understand these things. They by heart. Okay, many students, I have seen majority of the students, what they do, they by heart these addressing modes. They think they know, they understand, but actually they don't understand. For example, every student knows, let me tell you, every gate aspirant knows that this relative addressing mode you can use for writing relocatable code, but they don't understand what this means how to write the relocatable code with the help of piece with help of relative addressing mode, how to do that, what it means. Okay, so basically these things many students they don't understand. That is the reason I have made my, I can say, I have done my best to make you understand everything. What is relocatable code? What is non-relocatable code? How can you write relocatable code with help of relative addressing mode? How can you write relocatable code with help of base register addressing mode? Okay, so basically all these things with very clarity I have taught you. Please tell me, did you enjoy this? These three concepts: base register addressing mode, relative addressing mode, and indexed addressing mode. And these are very important. Okay, many questions, majority of the questions in the GATE exam, they will come from these three. Okay, so did you understand everything? Let me know. Now you can solve all the questions based on addressing modes. Okay, is this clear? Now these addressing modes also, let me teach you. These are not much important, but yeah, these are also in the our syllabus. So let's see auto increment and auto decrement addressing modes. Okay, now we will study auto increment, auto decrement addressing modes. So what are these? The name itself is telling you this will auto increment and this will auto decrement. Okay, so actually auto increment, auto decrement, what are these addressing modes? Let me teach you. In auto increment addressing modes, what will happen? And in auto decrement addressing mode, what will happen? Auto increment addressing mode. Okay, in this, what will happen? So let's see. This is actually exactly similar to register addressing mode. First of all, let me tell you the notation. Let me tell you the notation. The notation is something like this, that you have a register and you will write plus. This is the notation. Okay. Now you might be thinking, why this notation? Let me tell you why this notation. Because this is exactly similar to register addressing mode. This is exactly same as register addressing mode. Register indirect addressing mode. Register indirect addressing mode. Register indirect addressing mode. What is the difference? Only difference is, what is the only difference? Only difference is that after calculating effective address, okay, this R will be incremented. Okay, this R will be incremented. Content of R will be incremented. Content of R will be incremented. Is this clear? See, very simple. This is exactly same as your register indirect. This is exactly same as register indirect mode. Yes or no? Register indirect addressing mode. This is exactly same as register indirect addressing mode. The only difference is after calculating this effective address, the content of R will be incremented. What that means, let me tell you. This means that, first of all, you can see, did you understand why this symbol is used? Why we are using this symbol? Because this symbol means register indirect. This symbol means register indirect. Correct? Agree? This symbol means register indirect. And this symbol means auto increment. This symbol means increment. Okay. So very simple. So remember, this is what it will do. When you write in the instruction, if you write, let's assume this is you have written. Okay. Then what it will mean? It will mean this. What it will do, let me tell you. It will do two things. The first thing, you will calculate the effective address. Tell me what the effective address. Remember, first you will calculate the effective address. First effective address will be calculated. What is that? That is your register indirect. Okay, effective address will be content of R. Content of R will be effective address. Yes or no? In the register indirect, this happens or not? Please tell me. If you remember register indirect, in the register indirect, what happens? Let me know. Register indirect. In this, what happens? In this, R has the effective address. Your register has the effective address. Okay, if you go to that address in the main memory, you will find your data. You will find your operand. Agree? Yes or no? In the main memory. This is your register indirect. Agree? Please tell me. Understood? So very simple. So the same thing is happening here in the auto increment addressing mode. You can see what this will do. See, this will do two things. This will do two things. First, register indirect means effective address will be calculated. Then increment will happen. Then increment will happen. Then what will happen? Then increment R. Then increment R. By how much? Then increment R by how much? Like +1, +2, plus how many? Tell me. Plus 1, +2, plus how many? Tell me. +1, +2, how many? So increment R by operand size. Okay, by operand size. If operand size is 1 byte, then +1. If operand size is 2 byte, then +2. If operand size is 8 byte, +8. So that's it. Is this clear? So effective address is the content of R. That is the effective address. Content of R, is that the operand? Please tell me. Content of R, is that operand? No, that is not operand. I am saying content of R is effective address. In the register indirect, the content of R is effective address. If you go to that address, you will find your operand. Your operand is not in R. Your operand is not in R. In R, you have register. In R, you have address, memory address. So effective address is same as content of R. Then you increment R by operand size. So this is your auto increment addressing mode. Please tell me, is this clear? Let me know. A student is asking, in GATE exam, these notations will be given or not? Actually, these are very standard notations. So you should remember also. Okay, is this clear? But yes, they will be given. In the GATE exam, if you check all the GATE exam questions, all the previous year GATE exam questions, if you check, then in most of the questions, everything is defined. These notations are also defined. Everything is defined. There is no ambiguity. But remember, you should remember these notations. Okay, these notations, for example, this notation, you should remember this notation. So did you understand auto increment or not? Please tell me. Did you understand auto increment or not? Okay, very simple. Now let's see auto decrement. But remember auto increment. Please understand the symbol. Auto increment symbol is this R plus. So which thing will happen first? Which thing will happen first? First thing will happen this. This is register indirect. First this will happen. Okay. Then this will happen. Then this will happen. Increment R. Increment R. So remember, when you write like this, then what actually will happen here? Two things will happen. First thing, effective address will be content of R. Content of R. Okay, that is same as content of R. And the second thing will be, you will increment R. By how much? You will increment R. By how much? By operand size. Okay, by operand size. So very simple. This is your auto increment. Now let me tell you auto decrement. Now let me tell you auto decrement. The symbol of auto decrement, let me tell you, the symbol of auto decrement is minus and then this. Now you already understood what it means. You understood or not? You already understood what this means. First you decrement R. First you decrement R. Okay, in this addressing mode, first you decrement R. And then what you will do? And then what you will do? Then register indirect. So just think about it, what it means. So tell me what this will mean. Auto decrement addressing mode. So what this will mean? So remember, when you write like this, then what will happen? Two things will happen. Okay, two things will happen. What the first thing? Two things will happen. What the first thing? The first thing is you will decrement R. Okay, this is the first thing that will happen. You will decrement R. By how much? You will first decrement R. Remember, first you will decrement R by how much? By operand size. By operand size. Okay, first you will decrement R, and then the effective address will be content of R. Then that will be content of R. Is this clear? Please tell me. Let me know. Did you understand this? Please let me know. Is this clear? So remember, this is your auto decrement. So auto decrement, in the auto decrement, first we decrement R. Remember, in the auto decrement, first we decrement R. And in auto increment, what we do? And in auto increment, what we do? In auto increment addressing, what we do? First we find the effective address, then we increment R. Okay, so understand the difference. I hope you understood. Now, what are their applications? What are their applications? What do you think? What do you think? In which case you will do the increment, like you are incrementing. Okay, you are incrementing. In which case you will do increment, like first you will access this, then 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 you will access this. In which case you will increment? Please tell me. So you can increment in case of if data is at the successive locations. Yes or no? Applications used when data is at the successive locations. Can I say? When data present at successive data at successive locations. Agree with me? Yes or no? Agree or not? Like in array? Like in array? Yes or no? So you can see. But the point is very simple. Like list. Like a list. So remember, applications. Like remember, you are incrementing or you are decrementing, means when your data is at the successive locations, your data is at the successive locations, then at that point you can use auto decrement, auto increment. So this is used when data at successive locations. This is also used. Tell me, in your C language, in the high level language, when have you used this increment, pre-increment, post-increment, these type of things? Pre-increment, sorry, post-increment, pre-decrement. When have you used? In the loops, yes or no? Okay, in the loops. So for loops, yes or no? Is this clear? So remember, in loop implementation, you can use it. Okay, in the loop implementation, you can use it, because when you write a loop, then what you do? If you remember, in the high level language, like in the C level language, when you write a loop, if you are writing a for loop, then in the for loop, if you remember, three things you will write. Okay, there is something like I plus plus, something like that. Yes or no? Okay, there is something like that. I is less than equal to n, and there is something like that. I plus plus. So you can see, is this clear? So in the C language, this type of code you have written. Okay, agree or not? So very simple. The same thing I am writing here. So remember, for it's not for loop, it means loops. Okay, so in loop implementation, so you can see this is a used for loops. Okay, I can say this is used for loops. So I can write like this, that this is used for loops. You can use it for while loop also. Okay, you can use it for any loop. So basically in the loop implementation, you can use it. That's it. This is your chapter. So we have seen auto increment addressing mode. We have seen auto decrement addressing mode. One thing you can notice, how much you will increment? Tell me how much you will increment? How much you will increment? The size of data, the size of operand. For example, if your operand size is 1 byte, increment by 1. If your operand size is 2 byte, increment by 2. If your operand size is 4 byte, increment by 4. Okay, so very simple. So all these things we have already seen. So we have seen auto increment, we have seen auto decrement, everything we have seen. Okay, so this is your chapter. Everything is over. Your chapter is over. This addressing mode chapter is over. So please tell me, did you understand? Okay, so we have seen all the addressing modes. Every addressing mode we have seen. Each and every addressing mode we have seen. Okay. Now just a small topic, that is, how will you specify addressing mode in the instruction? You might be thinking, right? Like in the instruction, how will you know what the addressing mode? Okay. How the control unit will know? How the CPU will know what the addressing mode? For any operand, for any operand, what the addressing mode? How the CPU will know? How the control unit will know? So remember, specifying what is the addressing mode of the operand in the instruction. Specifying addressing mode in the instruction. Okay. So you can see, tell me, these symbols, will they tell the control unit? Will these symbols tell the control unit? Like for example, this hash symbol, will it tell the control unit that this is the immediate addressing mode? I am asking how the CPU will know what the addressing mode, how the CPU will know, how the control unit will know what is the addressing mode of an operand. So tell me, will these symbols tell the CPU? These symbols, will they tell the CPU? These symbols, will they tell the CPU? No, 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 no. These are only for us. Okay, these symbols we only use for us. Remember, these are just assembler syntax. These notations are for us, not for the CPU. Yes or no? These notations are for us, not for the CPU. These are assembly notations. These are just assembly notations. These symbol will tell us what is the addressing mode. Yes or no? They tell us. They tell us. Okay, humans. They tell us what are the addressing modes. So they tell us what are addressing modes. Which addressing mode? Okay, what are addressing mode? What is addressing mode? Okay, so these symbols will tell us what is addressing mode. But remember, inside your CPU, everything is binary. Yes or no? Yes or no? Inside memory, inside the computer, everything is binary. Inside computer, your instruction, that is just binary. That is a sequence of 0, ones. Yes, correct. That is a sequence of 0, ones. Yes or no? So this is just a binary. This is a binary sequence, nothing else. Now, here there are no symbols. Here we don't have no such symbols. Okay, yes or no? We don't have no hashtag, no these things. Yes or no? Is this clear? No these things. So these things are not there here. These things will not help you. So now you tell me. Now you tell me how the control unit will know. Now you tell me how the control unit will know what the addressing mode. Okay, what the addressing mode? Specifying addressing mode in the instruction means how the control unit knows. How the control unit, or I can say how the CPU knows the addressing mode of a operand. Knows addressing mode of operand. So there are two ways. Okay, there are two ways. There are two ways, remember. Okay, if you want to specify addressing mode in the instruction, there are two ways. Either it will be implicit, means control unit already knows it. Okay, control unit already knows it. Or you have to mention in the instruction. So there are two ways. There are two ways. There are two ways. What are those? The first thing, addressing mode is implicit. Okay, the first thing that is implicit means control unit already knows. Means control unit knows. Control unit already knows. Okay, means control unit already knows. Or the second way, either you can do this, means addressing mode is implicit. You don't have to do anything. We don't have to do anything. Okay, in the instruction, you don't have to mention anything. In the instruction, you don't have to mention anything. Means the control unit already knows what are the addressing modes of every operand. In any instruction, addition, subtraction, load, jump, whatever instruction you take, for every instruction, control unit already knows what the addressing mode. The second thing is, put a mode field. Put a mode field in the instruction. Is this clear? Put a mode field in the instruction. In the instruction. Okay. So these are the two ways. Is this clear? So either you put a mode field in the instruction, or you just assume that control unit already knows. Means the opcode will tell what the addressing mode. So remember, if you want to specify how to specify addressing mode, specifying addressing mode in instruction. In the instruction, what are the two ways? What are the two ways? Specifying addressing mode in the instruction. Okay, way one. What is the way one? The way one is that opcode itself will tell you addressing mode. Okay, means opcode itself indicates addressing mode. Indicates opcode itself indicates addressing mode to the CPU, to the control unit. Okay, is this clear? Means your opcode itself will tell what is the addressing mode. So very simple. Opcode itself indicates the addressing mode to control unit. This is way one. So in this way one, I can say no need to explicitly put in the instruction. Okay, no need to put addressing mode info in instruction, in the instruction. Okay, yes or no? In the instruction, you don't have to put addressing mode information. There is no need, because opcode itself will tell control unit what is the addressing mode. What is way two? What is way two? The way two is that put a mode field. Your instruction has opcode. Opcode will tell what is the operation, and this mode field will tell what is the addressing mode. Okay, is this clear? So very simple. So very simple. Remember, this mode field will tell you what the, this will indicate addressing mode. This indicate addressing mode. This indicate operation. This indicate operation. And this is your operand. Okay, is this clear? So you can easily see this will indicate what is the what is the addressing mode. You tell me how many bits we need. Let's assume there are 9 addressing modes. Assume 9 addressing modes available. Assume 9 addressing modes are available. There are 9 addressing modes available. Then how many bits you need here in the mode field to specify one mode? Assume 9 addressing modes are there. Total 9 addressing modes are there. Let's assume immediate, direct addressing mode, indirect addressing mode, base register addressing mode, relative addressing mode, index addressing mode, like this. So assume 9 addressing modes are available. So in the mode field, you need 4 bits. You need 4 bits. Yes or no? Is this clear? You need 4 bits. So that's it. Very simple. So you can see this mode field you can have like this. You can see if you have only two addressing modes, then what will happen? Okay, assume only 2 addressing modes. Assume only 2 addressing modes. 2 addressing modes in my CPU. In my CPU. Now tell me, in my CPU, I have only 2 addressing modes. How many bits you need for the mode field? How many bits you need? Only 1 bit is required, right? Okay. So you can see addressing mode. This will require 1 bit for mode. For mode field. Okay, is this clear? So you can see 1 bit for mode field. Only 1 bit is required for mode field, right? So very simple. And this is opcode. If you have 3 bits, then how many opcodes are possible? If you have 3 bits, then total 8 opcodes are possible. Okay, very simple. Let's move on now. Tell me the answer for this question quickly. Tell me the answer. The memory unit of a computer has 256K words of 32 bits each. The memory unit, okay, your physical memory, your main memory has 256K words of 32 bits each. Word size is already given to you, that is 32 bits. The computer has instruction format with 4 fields. There are 4 fields in the instruction format. Okay, in the instruction format, this is your instruction. There are 4 fields. What are those? You can see there is opcode field. There is a mode field to specify one of the 7 addressing modes. Okay, so remember there is a opcode field. There is a mode field. Okay, in the mode field, for mode field, how many bits you will need? For mode field, how many bits you will need? Remember, 7 addressing modes you want to specify. There is a mode field. Read this line. There is a mode field to specify one of the 7 addressing modes. You want to specify one of the 7 addressing modes. You want to specify one of the 7 addressing modes. So 3 bits are enough. Okay, for the mode field, 3 bits are enough. What about this register field? You can see there is a register field to specify one of the 60 registers. There is a register field where you want to specify one of the 60 registers. So here you will need 6 bits. Okay. And there is a memory address field. How many bits you will need for the memory address field? How many bits you will need for the memory address field? How many bits you will need for the memory address field? Your memory, if you remember, by default memory is byte addressable only. Don't consider word addressable. By default, your memory is always word addressable. Memory by default, that is always byte addressable. Okay, yes or no? Byte addressable. So you can see byte addressable. Is this clear? So tell me, your main memory size, what is that? Your main memory size, that is 256K into 4 bytes. So that is how much? That is 2 power 10. So that is 20, right? Okay, these many bytes. So total will be 2 power 20 bytes. Okay, total will be 2 power 20 bytes, means 1 MB RAM. You have 1 MB RAM. So how many bits for address field? 20 bits. 20 bits. And what is the opcode size? What is the opcode size? Tell me. Instruction size is given to you. That is 32. Instruction size is 32. That is given to you. Instruction size is 32. Okay, here you have register. Here you have memory. So you can notice here 6 bits. Here 20 bits. So this will be what? This will be 32 minus 3 minus 6 minus 20. How much is that? That is 3 bits. Okay, so that will be 3 bits. Very simple. Okay, let's move on now. Tell me the answer for this question quickly. Suppose a computer has 32-bit instruction format. Instruction size is given to you. Okay, with 4 fixed length field. There are 4 fields. There are 4 fields. Opcode field to specify one of 111 operation codes. So how many bits you need? In the opcode field, how many bits you need? You need total 7 bits. Okay. What about the address field? Address field to specify, sorry, addressing mode field. This is addressing mode field. This is address mode field. Addressing mode. Okay, you want to specify one of the 16 addressing modes. So that for that you need 4 bits. You want to specify one of the 16 addressing modes. You need only 4 bits. Register address field to specify one of the 70 available registers. So you need how much? You need 7 bits. Okay, for memory, how much you will need? That will be 32 minus 7 minus 4 minus 7. How much is that? How much is that? Tell me. That is 14 bits. That will be 14 bits, right? So you can see this question we have done, this question we have done, this question we have done. What is the answer for this question? Please tell me. What is the answer for the last question? Given that memory is byte addressable, memory is already given to you, that is byte addressable. How much memory is there? How much memory is there? So how much memory? That is 2 power 14 locations, 2 power 14 bytes. Okay, so that is your 16 kilobyte. 16 kilobyte memory, 16 KB memory. Let's move on. Tell me the answer for this question. A processor uses, there is a processor which uses fixed length 32-bit instruction format. Instruction size is given to you. Instruction size is already given to you. The processor has 98 instructions in the instruction set, right? The processor has 98 instructions. Means processor has 98 instructions means in your instruction set, you have 98 instructions. Instructions can have 0 or 1 or 2 or 3 operands. Okay, your instruction, it can have 0 or 1 or 2 or 3 operands. The instruction format is given to you. Anyone want to tell me why this type of format? Why this type of format makes sense? Why this format makes sense? Because different operands can have different addressing mode. Yes or no? Different operand can have different addressing mode. Different operand can have different addressing mode. Yes or no? This operand can have register addressing mode. This operand can have memory addressing mode. This operand can have relative addressing mode. So you can see different operands, they can have different addressing mode. So this is the instruction format that is given to you. Assume there are 10 addressing modes. Total, you have 10 addressing modes in the system. You want to use 3 operands. Okay, you want to use 3 operands you want to use. The operands must all be in the registers. Every operand must all be in the registers. How many registers should your processor have? This is the question. How many registers your processor can have? Tell me. This is the question. Did you understand the question? Instruction format is given to you. This is the instruction format. There is 32 bits. Instruction format is 32 bits. Instruction size, that is 32 bits. Okay. There is opcode. How many bits for opcode? Just tell me this point. How many bits for opcode you need? How many bits for opcode? Processor has 98 instructions. Read this. Processor has 98 instructions means your instruction set has 98 operations. Your instruction set has 98 instructions. So opcode needs how much? That will need log 98 seal, and that is 7 bits. Then there is operand 1. Operand 1, mode 1. Okay. There is operand 2, mode 2. There is operand 2, mode 2. There is operand 3, mode 3. Mode 3. Now tell me, for mode, how many bits you need? For addressing mode, how many bits you need? For this addressing mode, how many bits you need? There are 10 addressing modes. There are 10 addressing modes. Okay, so for this you need log base 210 seal. That will be 4 bits. 4 bits here, 4 bits here, 4 bits here. Okay. For operand, it must be a register operand. The question is already telling you operand must be register. Yes or no? Operand must be in the register means addressing. Oh, okay. Tell me what this line means. Just tell me what this line means. The operands must all be in the register. Operand is in the register. Your operand is in the register. In the register, you have operand. You have operand in the register. Which addressing mode is this? Your operand is in the register. Your operand is in the register. This is a register addressing mode. Okay. This is register addressing mode. Correct. So you can see for this, what you will do in the instruction, you will put the register address. In the instruction, you will put a register address. Yes or no? So here, what you will do? Very simple. The register address you will put here. So how many bits you need? For register, how many bits you need? I don't know. Let me say X bits. Let me say X bits. Let me say X bits. Okay. So you tell me, basically, for these 3 operands, how many bits are remaining? See, I am asking for these 3 operands, how many bits are remaining for operand 1, for operand 2, for operand 3? How many bits are remaining? How many bits are remaining? That will be 32 minus, that will be 32 minus 7 minus 4 minus 4 minus 4. How much is that? That is 13 bits. Okay. In 13 bits, you have to put 4 registers. So tell me, here how many bits must be there? How many bits must be there? So Only 4 bits, right? Only 4 bits. Yes or no? Okay, so because this is the value of x, this is x, this is x, so this x will be 4 bits. Is this clear? One bit will be one bit wasted, one bit unused. Yes or no? One bit is unused. Is this clear? One bit will be unused. So very simple. Okay, so remember 4 bits. So how many registers? With 4 bits, how many registers you can have? Okay, if your register address is 4 bits. So how many registers you can have? So maximum 16 registers I can have. I can have maximum 16 registers. Is this clear? So for this question, the answer is how many registers we can have? Maximum 16 registers I can have. Maximum 16 registers. Is this understood? Please tell me. Please let me know. Okay. So this question is interesting or not? See, this question is telling you many things. This question is telling you many things, that different operand can have different addressing mode. Okay. This operand can have direct addressing mode. This operand can have register addressing mode. So that is the reason this instruction format makes sense. This instruction format makes sense. So this type of instruction format also they can give you. Okay. Let's move on. Tell me the answer for this question quickly. This question is related to PC relative addressing mode. Consider a PC relative branch instruction is there. Okay, your branch instruction, which is stored in the main memory at address 250. Okay, this branch instruction you have stored at, there is a jump instruction, right? Okay, there is jump instruction and some offset value, let's call it A. And this this is located at 250. This is the memory. This is located at 250. This is the memory. The question is saying that the relative address field contains value 200. Address field contains, remember, the address field contains value 200. So this A is 200. This A is 200. What is the possible PC value immediately after execution phase of branch instruction? Tell me. So you can see when you fetch it, when I fetch it, then what will happen? If I fetch it, what will happen if I fetch it? If I fetch this, then what will happen? Then the program counter value will be incremented. Once I fetch this, then the program counter value will become 251. Yes or no? It will become 251. Okay. Now after that, decoding will happen. After that, decoding will happen. Yes or no? After that, decoding will happen. See, everything I'm telling you one by one. First instruction fetch will happen. First instruction fetch will happen. Correct. Second, decoding will happen. In the decoding, you will find out, okay, this is the jump instruction, right? Yes or no? In the decoding, you will find out that this is the jump instruction. Because this is the jump instruction, so what is the third thing will happen? So what is the third thing will happen? Tell me. Tell me what is the third thing that will happen? The third thing will happen is update PC. Update PC. Okay, so the third thing that will happen, that will be update PC. So update PC by what? Update PC by what? That will be update PC by 200 plus 251. Yes or no? So that will be 451. That will be 451. Is this clear? Okay. Is this clear? Please tell me. Did you understand this question? Did you understand this question? Let me know. Let me know. Okay. This question can become more interesting. Let me tell you. This question can become more interesting if I say this branch instruction is a conditional branch instruction. This question can become more interesting if I say this is conditional branch instruction. This is a conditional branch instruction. Okay, now this question can become more interesting. Now tell me the answer, because the question is asking what are the possible PC value. Okay, after the execution of branch instruction. After the execution of branch instruction. Now the possible values, remember, either they can be 451 or they can be just 251. Okay, yes or no? Either 451 or 251. 451 if branch taken. Yes or no? If branch taken. And this value if branch not taken. Yes or no? If branch not taken. If branch not taken. So very simple. Is this clear? Please tell me. Okay. So this is very easy question. Now let's move on. Tell me the answer for this question quickly. A PC relative addressing mode branch instruction is there. PC relative addressing mode, there is a branch instruction and the instruction size is 2 bytes. The instruction size is given to you, that is 2 bytes. Okay. The address of instruction in the decimal that is given to you. Determine the branch target address. We have to find the branch target address. If the signed displacement in the instruction is this, okay, in the hexadecimal, this displacement is given. This displacement is given in the hexadecimal format. Now, what will be the answer? See, very simple. In the question, this is your memory. You have a jump instruction. Where is your jump instruction? Where is your jump instruction? You have jump instruction. Okay. So at which location? At this address, 56028. At this address. Okay, you have a jump instruction. And what is the offset value? Jump A. Okay, jump A. What is this A? This A is already given to you. In the hexadecimal, this is given. In hexadecimal, this value is given. This value is given in the hexadecimal. Okay. And remember, this instruction size is 2 bytes. Yes or no? This instruction size, that is 2 bytes. So the PC will point to where? When you fetch it. When you fetch this instruction, the PC will point to where? Please tell me. When I fetch this instruction, I am fetching this instruction. If I fetch this instruction, now the PC will point to where? PC will have what address? PC will have 56030. This address PC will have, right? Yes or no? So very simple. Okay. And this is already given to you. This is the signed offset. Remember, this is the signed value. This is the signed offset. How much is this in the decimal? How much is this in the decimal? Is hexadecimal is given to you. That is 0F82. Okay, 0F82. Okay. So tell me, how much it will be? How much it will be? You just calculate in the decimal. Just convert in the decimal. So what that will be? In the decimal, if you convert, then what that will be? This you multiply with 16 power 0. Yes or no? Okay, just convert into decimal. Let's convert into decimal. So what you will do? If you want to convert this into decimal, then what you will do? This 2 you will multiply with 16 power 0. This 8 you will multiply with 16 power 1. This F means 15. This you will multiply with 16 power 2. So that's it. Okay. So what this will be? Anyone? Anyone, what is this value? How much value I will get? Can you tell me in the decimal? How much value we are getting? 3970. 3970. So this is the displacement. This is your offset A in decimal. So now you tell me the answer. 3970. So final answer is what? 3970. So your final answer will be what? Tell me. So now you have the value. A is 3970. Okay, so branch target address, what that will be? Branch target address, what that will be? That will be, just add these two. Just add these two. 56030 plus 3970. Okay, plus 3970. Is this clear? That's it. So very easy. So this will be your final answer. Okay, let's move on. One interesting question I want to ask you. If this was FF82, now what will be the answer? If this A was FF82, now what will be the answer? Let me ask you this variation. if A is if A is this, okay, if A is this, if A is this, then then answer will be what? Please tell me. Then answer will be what? Remember, this is a signed number. This is signed number. Now this will be negative. Now you cannot blindly convert. Yes or no? See, this is just I'm telling you that now you cannot blindly convert. If you directly do this, this will be a huge mistake. Yes or no? If you do this 15 into 16 power 3 plus 15 into 16 power 2 plus 8 into 16 power 1 plus 2, if you do this, this will be a huge mistake. Yes or no? Agree with me? A small point I'm making. I'm just making this small point. Did you understand? Okay, don't worry about the answer. I'm just making a small point. Did you understand the point that I'm trying to make? I am just trying to make a small point. Okay, just tell me what the A in decimal. Is this clear? Is this clear? That the point I'm making, did you understand? So here, remember, this is a signed number in 2's complement. Now, what you will do? So now how to find in decimal? Now, if you want to find this in decimal, then what you will have to do? First, you expand this. It is 1111, 1111. Then what is 8? What is 8? 8 is 1000. And what is 2? That is 0010. Tell me what is this value in 2's complement. This is signed value in 2's complement. What is this value? If you remember from my 2's complement lecture, these ones you can ignore. So far, these ones you can ignore, right? If you remember from my 2's complement, in the 2's complement, these extra ones you can ignore if you remember. Okay, do you remember this? In 2's complement, these leading ones do not matter. For example, if you have this value, this will be same as these leadings one will not matter. Okay, this one will matter. Of course, this one will matter, but the remaining ones will not matter. For example, only this will matter. Only this matters. Only this matters. Other than this, if you are putting 1 does not matter. Other than this, if you are putting, okay, this will be same as what? This will be same as if you are putting this. If you remember, do you remember this? From my 2's complement lecture in the digital logic. In the digital logic, we have seen this. We have seen this. Yes or no? Okay, so now you tell me, what is this value? This value will be same as if you calculate this value, 1000, this. And what this will be? The weight of this will be minus 2 power 8, minus 2 power 7, plus, and this will be 2. So how much is this? So that will be minus 28 plus 2. That is minus 126. That is minus 126. Okay. So your final answer will be what? Then you tell me the branch target. Then tell me the branch target. Tell me what will be the branch target address? Your final answer. You tell me now the final answer. So the final answer, your branch target address. Branch target address will be the PC value, that is 560 30, 560 30. Okay, the PC value, that is 560 30 plus this value, this minus 126. Okay, is this clear? Please tell me, did you understand this point? This is very important point, right? Okay, many students, they can make mistake. Many students, they can make mistake. Yes or no? Is this clear? Please tell me. So remember this, because this is a signed value in 2's complement. So you have to take care that the sign bit should not be 1. Okay. If you are converting to decimal, you should take care. That's it. Okay. So I hope you understood everything. So this is your addressing mode. All the variety of question I have taken. Please tell me, did you enjoy? One thing I want to tell you, every variety of question I have taken in these sessions, in these lectures, every variation, every small point I have told you. So did you understand addressing mode? From addressing mode, whatever question they ask you, okay, they ask you any question they ask you, can you solve it? Please tell me. So this is your addressing mode chapter. Okay. Thank you, everyone. Thank you. And one more thing, these addressing mode lectures I am uploading on the Go Classes YouTube channel. Please comment there. Okay. Please comment your feedback there. Because I think one thing I can promise you, you can study from any other coaching institute. Okay. Or you can study from YouTube. Okay. Basically, you can study from any video lectures other than the NPTEL, of course. I'm not talking about NPTEL or the standard lectures. I'm not talking about those. I'm talking about coaching institutes. Okay, if you study from any video lectures, you will never, you will never get this much, I can say, understanding of addressing modes. Okay, this much clear understanding, crystal clear understanding of addressing modes, you will not get. Okay, so that is what I have done. Basically, I have tried my best to give you crystal clear understanding of addressing modes. You can explain what is program relocation, how the relative addressing mode can be used for program relocation, how program relocation can be done using base register addressing mode, what is index addressing mode, how to implement array, how to implement pointer. Okay, so basically everything in a detailed way I have told you. So please, I have a request to everyone who is watching this video. Please comment on the Go Classes YouTube channel under this video. Okay, please comment, please put a comment so that we can reach more students. Okay, so basically you can see we are providing this quality content from the standard resources, but still there are a lot of students, there are a lot of GATE CSE aspirants who don't know about Go Classes. Okay, they don't know about Go Classes, and they keep enrolling in some, I can say, in poor resources, in poor institutes. So basically, I want to ask you one thing, that if you like the content of Go Classes, then please put a comment so that we can reach, our video can reach more students. So please comment and like. Okay. And if you can share, that is also very good. If you can share, you can share in the WhatsApp, Telegram groups where GATE aspirants are there. Okay. If there is a Telegram group, if there is a WhatsApp group in which you have joined, so please share these videos. If someone is asking from where to study addressing mode, if someone is asking addressing mode question, then you can share our Go Classes addressing mode lectures. You can share. Okay. So thank you, everyone. Thank you so much.